Welcome to Compute 201, Autoscaling, the fleet management solution for planet Earth. Are you guys having a good reInvent? Yeah? Good. I'm glad you are. I am too, although I have to admit, it's Thursday, it's been 4 days in Vegas, feeling a little bit tired, a little bit sleep deprived. Let me tell you a story about sleep deprivation. So this happened to me 2 weeks ago. I was at home, got up one morning after a particularly short, somewhat sleep-deprived night. I managed to pull myself together, and I was about to head off to work, where in front of my door, there was a garbage bag. Now, I don't know about you, but at my place, that's a not-so-subtle sign that, Andre, it's garbage day, and it's your turn to take the trash out. So I grabbed the bag of garbage, grabbed my lunch, headed off to work. Left the garbage by the side of the road, and proceeded on my way to work. Made it almost all the way there before I realized I was carrying a bag of garbage and had thrown out my lunch. It's amazing what sleep deprivation can do to you, isn't it? Well, today, we're going to talk about a service which has been enhancing the sleep quality for thousands of AWS customers. And this is, of course, autoscaling. We're going to come at it from 3 different angles. Firstly, I'll tell you a bit about how you can easily, quickly adopt autoscaling's fleet management capabilities to enhance the availability of your application. Then we'll move on and talk about how your application can be enhanced to keep up with changing demand using autoscaling's dynamic scaling capabilities. And when we get to this section, it's going to be a special treat because my co-presenter today is from NASA's Jet Propulsion Laboratory, and he'll tell us about an extremely compelling application of autoscaling's dynamic scaling, which I think you'll find very interesting. Then we'll wrap up. I'll give you a glimpse into the future of autoscaling and how we're making that future real already today. First, I'd like to begin by disabusing you of 3 common myths that sometimes prevent customers from getting the most out of autoscaling or even trying it out. Myth number 1. My application doesn't need scaling. Just an app, stable demand, no peaks and troughs. Why on earth would I ever need a service called autoscaling? Well, I wouldn't blame you for thinking this, given what we've called the service, but the truth of the matter is, autoscaling, even if you have no interest in scaling at all, monitors your instances and heals them if they become unhealthy. So again, even if you have no interest in scaling, autoscaling's fleet management may have some benefit for you. Myth number 2, autoscaling is hard to use. Now, it's certainly the case that as you progress down your journey of adopting autoscaling, there are some new concepts. But I'm going to prove to you today, I'm actually going to teach you how you can get started with autoscaling's fleet management in just a few minutes with just a few clicks. Myth number 3, my instances are stateful or unique. They're somehow special to me. I don't want autoscaling to arbitrarily select those special instances to be terminated in the event that it's scaling in. So stateful instances could be, for example, a master in a master-slave type of application. Or maybe if you're building gaming applications, it's a game lobby that still has players in it. Or for example, it could be an instance that's picked up a long-running workload. It's been running for several hours, you're almost done, you've paid for that time. You don't want it to be arbitrarily terminated. Well, I'll show you today, again, I won't just tell you, I'll show you and teach you how you can use autoscaling to work perfectly well with stateful instances. Now, autoscaling use cases divide into 2 broad categories, fleet management and dynamic scaling. Fleet management is by far the most common application of autoscaling. It's the main focus of our talk today. So let's begin with that. Here's an example where you have an autoscaling group. It's got 3 instances in it. And autoscaling has made automatic the fairly manual processes of provisioning these instances, loading them up with the correct Amazon machine image, ensuring that they're healthy. You also have the opportunity to provide custom launch workflows as these are coming into service. Once the instances are ensured to be healthy, they're placed behind the load balancer to serve traffic for your application. Now, Imagine that one of these instances becomes impaired. Now, the way we know this is it becomes unresponsive to autoscaling's health checks. Autoscaling is able to detect this condition, terminate the instance, and provision a brand new healthy one in exactly the same image as the ones that are currently in your autoscaling group. All this happened without any pagers going off in the middle of the night, without sleep deprivation. Now, the second category of use cases as you progress on your autoscaling adoption journey is dynamic scaling. And the idea here is that autoscaling enables you to respond to dynamic changes in the load that's being placed on your application. So in this example, I've got my 2 instances in the autoscaling group, and we're looking at CPU utilization as a metric indicating load on the app. So we can see here we were okay for a little while, but the CPU utilization spiked up. Okay? So this potentially could be harmful to the performance of your application, ultimately its availability. Autoscaling can detect the spike, provision additional instances, in this case 2 of them, place them behind your load balancer, such that on average, the CPU utilization across your 4 instances now drops back down to a normal level. Your application remained available, it remained performant. And of course, if the CPU utilization were to drop even further, the additional capacity that was provisioned could be removed in order to save you money. So let's talk a little bit about fleet management. I'd like to propose kind of a simple test here. These are 3 statements. If you agree with them, or if there are things that they sound like something you would say, then there may be some value in exploring fleet management with autoscaling for you. Statement number 1, I have instances that are serving a business impacting application, something that I care about, something that's important to me or my company. Statement number 2, if my instances become unhealthy, I would like them automatically replaced, please. Statement number 3, I'd like to have my instances distributed across availability zones in order to maximize the resilience of my application. Stated a different way, if you have only instances that you don't care about that are doing things that are uninteresting to you, if you like the experience of being paged in the middle of the night to do manual instance replacement on instances that you don't care about, and if you like to keep all your eggs in one availability zone basket, then it may well be that there's not much I can do for you. However, for most of you, I suspect that you will find some value here, and so we're going to continue with the presentation. In the form of a demo, if we could please switch the video to the alternate feed. So here we are in our US West 2 region. I've got 2 instances. They are not currently in an autoscaling group. They're just 2 instances out there in an existing application. And they happen to both be in availability zone A. Now, I've just gone to this presentation on autoscaling, and I heard I can enhance the availability of these instances fairly easily. How do I do that? Well, the first thing you do is go to one of these instances and right-click on it. Proceed to the instance settings option and say attach to autoscaling group. I'm going to give this group a name and then click attach. If I stopped here, I would already have enhanced the availability of my application. So what's happened behind the scenes here is autoscaling created an autoscaling group for us. It created a launch configuration in the image of the instance that I already had. So this just happened behind the scenes for me. And autoscaling is already monitoring this instance for health. If anything unfortunate happens to it, it will be terminated and replaced with a brand new healthy instance. Okay? So that really was just a small number of clicks. So let's go see what we have created here in the autoscaling group. So I'll click on this hyperlink here, which takes me to the autoscaling console. And if I go to the Instances tab here, of course, everyone memorized the instance ID. You can see this is indeed the instance that I had before. It's been placed in my autoscaling group for me. and it is currently being monitored. Now I've got 2 instances, so what I'm gonna do now is edit the properties of the auto-scaling group. As you can see, it has a desired size of 1 and a maximum size of 1. So I'm gonna go ahead and increase the maximum size to 2 so I can fit an additional instance in here. So edit that, change max to 2. Go ahead and save those changes, and then I'll return to the instances view of the EC2 console. Take my second instance, attach it to an auto-scaling group. This time I'm gonna select an existing group, the one that I already had, and attach. So now my 2 instances are in the auto-scaling group. They're being fleet managed by auto-scaling, they're being protected. If I flip back to the auto-scaling console and look at the instances, you can see that there are 2 of them in there. One of them is in a pending state, so it's still being attached to the auto-scaling group. So while that's happening, let's look at the launch configuration. So remember I told you this launch configuration was automatically created for us by auto-scaling. It has the properties that reflect the initial instance from which I created the auto-scaling group. It's got the Amazon machine image that I was using, the keys that are involved, the instance type, security groups, et cetera. And so if I were to grow this auto-scaling group, future instances would be stamped out using this as a template. Now, the next thing I'd like to tell you about is aggregate metrics. So I'm gonna flip back to our main auto-scaling group console here in a second and go over to the monitoring tab. So aggregate metrics enable you to have a view of your entire fleet of instances running in auto-scaling groups. So you could have a look at, for example, the average CPU utilization. You could see how they're doing in aggregate with their memory utilization, network and disk I/O, many different types of metrics aggregated at the auto-scaling group level. So this is very useful if you're trying to benchmark your application, you want to profile it, you're interested in doing some capacity planning perhaps, or just understanding how your app responds to different type of stimuli or pressure. And so the way to access this free feature is by enabling group metric collection, and then I'm gonna switch over to the CloudWatch console where we can have a look at the metrics that are available there. So I'm gonna go to EC2, and I'll say I want my metrics by auto-scaling group. Type in the name of the auto-scaling group that I just created, and you can see many different metrics available to me here. As I said, CPU, memory, network I/O, disk I/O, a variety of things. So let's go and pick CPU utilization. And you can see here that my CPU utilization has been graphed over time. Obviously, this was running in the background for some time, and it's accumulated data. So I'm not doing much with these instances right now. They're running below 1% average CPU utilization. If there was some more stuff going on here, I'd be able to see interesting periodicity in my workloads, for example, peaks and troughs of utilization, maybe be able to derive some interesting insights that would help me with capacity planning. And of course, average isn't the only aggregation that I can do. I could also look, for example, at min and max values. And actually, with the recently released CloudWatch percentile feature, I could look at, for example, my P99 CPU utilization or P99 memory consumption. Those were released actually after I recorded this video, but there's some value there as well. Equally, I can look at different aggregation periods, so it doesn't have to be 5 minutes, could be 1 minute, could be something less granular. And so that's it for aggregate metrics presentations. So the next thing I'd like to show you is a little something we call auto-scaling rebalancing. So I told you at the beginning of the presentation that both of my instances are in availability zone A. And if you've been with AWS for a while, you've been going to the sessions this week, you've probably heard that it's not necessarily a best practice from a resiliency perspective to have all your instances in the same AZ. You'd like to distribute your capacity to maximize resilience to localized failures, right? So auto-scaling can do this automatically for you. So the way I'll do that is go to the auto-scaling group properties and edit them. And so you can see I've got availability zone A here in the subnet that I've specified. I'm gonna add a second one, which is availability zone B. I've got 2 availability zones now available to my auto-scaling group, right? I started off again with the 2 instances in A, and what we're gonna observe in a second here when I save this is auto-scaling is gonna take those 2 instances and redistribute the capacity evenly amongst the 2 AZs. So save that. Flip over to the instances view again. And what we see here is that we have a new launch that is pending in availability zone B. This was initiated automatically by auto-scaling in an attempt to rebalance capacity. Now, obviously, I've accelerated the time scale a little bit here, but what we now see is that instance has come into service, and one of my instances in A is being terminated. So I've still got my 2 instances, but they're now redistributed, so I have balanced capacity. Okay, that instance is shutting down still in A, and ultimately it will be terminated. Now, I also told you auto-scaling monitors your instances and replaces them should they become unhealthy. So we're gonna go ahead and do that. What I'm going to do is label the instance in availability zone B as a victim, just so that we can recognize it when it suffers an unfortunate fate in a moment here. And behind the scenes, I'm going to impair this instance. Auto-scaling will detect that, shoot it, and replace it. So here's the victim. The impairment has occurred, and that instance is shutting down now. Auto-scaling is terminating it. And if we accelerate, it's now fully terminated, and I have a new launch pending in availability zone B. Now, it's no accident that that launch is occurring in availability zone B. I told you auto-scaling will maintain balanced capacity. And so, again, my instance died in B. I'm replacing it in B balance. And that launch is pending, and in a moment that will complete. Okay. So the final thing I'd like to show you in this quick demo here is to sort of make good on the assertion that I had when I was dispelling the myths originally. I told you auto-scaling works well with stateful instances, those instances that are precious to me, the ones that I don't want to be selected for termination arbitrarily when auto-scaling is looking to scale in to reduce capacity to save you money. So I'm gonna go ahead and label my instance in availability zone A as stateful. Again, just a label so we can recognize it when we see what happens later. And I flip over to the auto-scaling console now. And I'm gonna find that instance in A, right-click on it, instance protection, and set scale in protection. Go ahead and accept that. So this instance is now protected. So in the event that the auto-scaling group needs to shrink because the excess capacity is no longer needed, auto-scaling will be hunting for an instance to terminate, right? This one will not be selected. The other instances will be preferred. So we're gonna cause exactly that eventuality now by editing the auto-scaling group properties, switching the desired capacity from 2, which is the current capacity that I have, down to 1. So I had 2 instances, and I've told auto-scaling I only want 1. When I switch back to the instances view, I can now see that my instance in availability zone B is terminating. My instance in availability zone A is not terminating. My stateful instance was indeed protected. This wasn't a coincidence. It was exactly a result of what we just did. So that concludes the demo. If we could switch back to the main presentation, please. So you just saw 4 very important fleet management aspects of auto-scaling. You saw that with literally a few clicks, I was able to create an auto-scaling group based on instances I already had, have the instance placed in the auto-scaling group, monitored for health, and replaced should it become unhealthy. You also saw how aggregate metrics can be used to benchmark your application, to profile it, to understand in aggregate the performance of your fleet. We also saw how auto-scaling's rebalancing feature can ensure that your capacity is automatically distributed amongst several availability zones to maximize the resilience of the application. And then finally, you just saw me demonstrate how you can use auto-scaling with a stateful application. And by the way, none of this really had anything to do with scaling. This is just basic fleet management and AWS best practice. But we are going to talk a little bit about scaling because it is an auto-scaling presentation after all. So dynamic scaling is the intelligence in auto-scaling that confers the elasticity to the cloud. It enables your EC2 compute to grow and shrink in response to changing demands on your application. You've heard probably from several customers this week, including Netflix, how they use this to grow and shrink their compute. One example that I particularly like is Reckon, who provides accounting software in the cloud, and they use auto-scaling with a scheduled scaling feature to grow their compute in the morning when they expect a bunch of customers to pounce on their platform, and to shrink it in the evening when everyone is going home, demand is less, and they have an opportunity to save money. So let's talk a little bit about this scaling on a schedule feature. So many applications have this regular time-bound pattern of peaks and troughs of demand where you have a really good opportunity to use auto-scaling. So with scaling on a schedule, you can inject recurring scaling events such as scale out in the morning, as I said, to meet increasing demand, or scale in the evening, or scale out at the end of the month when you're doing your month-end bookkeeping, keep your scale low throughout the rest of the month, right? You also have the ability to inject one-off scaling events. For example, if it's election night or Super Bowl Sunday and you're scaling out your fleet of video streaming servers, you can do that as well as a one-off and non-recurring event. So the benefit here is that you can scale quite high and maximize the availability and performance of your application when you need it, but you don't always have to be scaled to that peak level, and you have the ability to save money during the downtimes. Now, reactive scaling policies are another feature of auto-scaling that you can layer on top of scheduled scaling policies if you wish. And these give you the ability to really respond to the dynamic changing conditions in your application. And so here's an example where we've got an auto-scaling group of 4 instances. Their metrics are being collected. For example, we're looking at average CPU, or perhaps it's memory utilization. And these get collected and aggregated into CloudWatch. And in the event that the metrics exceed a threshold that you configure, for example, my CPU utilization is above 60%, or the length of the queue that I'm using to buffer work for my auto-scaling group of worker instances has exceeded a certain level, an alarm fires. This alarm is bound to a scaling policy that specifies what to do in the event of an alarm breach. And in this case, for example, we can trigger a scaling event that says add 1 additional instance, or grow my fleet capacity by 25%. You can do it either way, in the absolute or the percentage way. And so the additional capacity is provisioned, software is loaded. Again, you had the ability to customize the launch workflow, and this gets placed behind a load balancer if you're using one, such that the performance of your application is enhanced in the presence of increased traffic. And of course, when the capacity is no longer needed, it can be taken away to save you money. Now, rather than hear me talk too much in the abstract about dynamic scaling, I told you we're in for a treat today. We're going to hear from NASA's Jet Propulsion Laboratory about an extremely compelling application of auto-scaling used for advanced rapid image analysis. And today is actually particularly special because our presenter flew to Saudi Arabia on Monday and was so excited about coming to present this use case to you today that he actually flew back and just got off the plane like 2 hours ago. So I'd really appreciate it if you give a warm welcome to Hook Hua.
So Andre just told us about some of those reactive policies for auto-scaling, and I think what we'll talk about today actually is a good demonstration of how we actually are using reactive policies with auto-scaling. And actually, for our particular use case, our reaction is actually based on real Earth events, like earthquakes, for example. And we'll talk a little bit about how we're actually integrating together many of these types of actually remote sensing data, but more specifically, Earth observational data from synthetic aperture radar. So we're talking about how we're analyzing solid Earth deformation using Earth observations and using that with cloud computing and then moving that type of capability into auto-scaling. And from that type of auto-scaling, we're actually better able to react dynamically to demands of analysis. Like, for example, whenever we have an earthquake, our activities typically spike up. And then maybe 2 weeks or so after an earthquake, for example, demand kind of dwindles down a little bit. So in many ways, this type of reactive capabilities fits really well with auto-scaling. And here you can see that when you look at disaster response, for example, what typically happens with synthetic aperture radar is that many of the analysis that takes place is actually more artisan than automation. And I think what we're talking about today is a lot of the efforts that we've been making in terms of automating a lot of that, moving that type of analysis more into not just a cloud computing environment, but automating a lot of those capabilities and all of the subtleties that you would find in the artisan of it. On the left there, you would see an image of some kind of a heat map that shows how often coverage is taken of different areas of the Earth. Particularly the polar areas, there are a lot more coverage from satellites as they repeat their observations circling the globe. And a lot of the things that we're talking about actually includes different kinds of analysis, some ranging from the temporal-based type of records based on like GPS observations, and others are more like spatial deformation maps that kind of show major areas of a ground change, basically. And the ones that are of particular interest are the ones that are called coseismic imagery, coseismic deformation maps particularly. And those typically are observations that are made before an earthquake or a flood or a hurricane, and also another observation made afterwards. So when you look at the two that spans across a particular event, those imagery actually are the ones of particular interest because they really show the aftermath change from a particular event. And so a lot of what we've done is actually based on the analysis of these type of things. And we're actually, this project is called ARIA, not really similar to the hotel, but ARIA is an acronym for Advanced Rapid Imaging and Analysis. And in this particular project, it's a collaboration effort between JPL and Caltech. And in this project, we actually integrated together multiple different sensors and observations, not just the radar instruments, but GPS networks, optical imagery. We put it all together into basically a fully automated system, all running within Amazon and all fully auto-scaled. And the basis of that is that it's actually pulling together multiple different data products, data streams coming in from different data centers around the globe. And it all gets pulled into Amazon regions. And it's actually processing it through and running these types of continuous monitoring type of capabilities where it's processing the data. And it's going through different workflows and pipelines. And in the end, we get multiple different imagery. And during these events, we typically want to do that type of spiking up of activity and down. But concurrently with that, we're actually doing multiple different kinds of other processing or other analysis. And during these types of analysis, we actually want the system to automatically scale up and down based on the demand and the needs of what we're analyzing. But we want to be able to fully automate that. And essentially, that's what we've been doing here. And this is an example chart here that kind of shows, it's an illustrative example that shows all of the different regions that we've been looking at in terms of the analysis capabilities. It includes, for example, continuous monitoring of the Kilauea volcano in Hawaii. But it also includes, like the big one you see one there near the center, California. We're analyzing all the different fault areas of California, as well as like inundation for hydrology, for example. And due to the high repeat cycle near the polar regions, we have a lot of coverage over Antarctica. There's the Rutherford ice stream analysis there. But overall, these are more like the background type of analysis. But whenever there's an earthquake, like the New Zealand earthquake or the Kumamoto, Japan earthquake, or the recent earthquakes in Italy, our system responds by itself. We are actually tapped into the USGS event feed, and our system basically has been set up to react via auto-scaling to essentially scale up whenever there's an earthquake, and we have these workflows that kick in. And the system basically aggregates the right data and fully automates and processes and analyzes the results pretty much automatically. It's actually quite lights out type of operations. And in this diagram here, you can kind of see this is like a pictorial view of what we're doing within an Amazon environment. In this diagram, though, we're looking at the process control and management, where there's an illustrative workflow pipeline of where we process data from raw to more refined, more informational products, things that show like deformation or change within the Earth, for example. And each of those pipelines, each of those boxes, actually, the processing step, in the NASA community, they call it PGEs, a product generation executive, but it's essentially a processing step. And we have many different processing steps. And the way that we have developed it is that we have a suite of EC2 instances that basically run the process and control management. And they're fully redundant. They're decoupled in terms of functional capabilities for high performance, like Elasticsearch services-based search and catalog, analytics, real-time metrics, as well as resource management. But overall, they're actually controlling a fleet of workers. And each of these fleet is actually fully auto-scaled. So each of these are an auto-scaled group, and they are managed and coordinated by the process control management set of services. But we have many of those type of fleets there. So each of those auto-scaling groups is actually controlling and managing independently of all the other ones the processing and an analysis within an overall pipeline. But collectively, they are working together to actually process the data one step at a time as it matures from raw data all the way up to some more of the refined data products. And then, here it's an illustrative view, but it's kind of, we're trying to convey the notion that there is the notion of, there's diversity amongst the auto-scaled groups as well as where they are within the availability zones. They could be spanning, one auto-scaled group could span multiple different availability zones, for example. But overall, this type of capability of running multiple auto-scaling groups we found worked really well in terms of ensuring that classic architectural principle of having each component run maximally at its own independent rate. And then the final data is actually delivered to different communities, basically. This is an example here where we want to convey the notion that within our science data system that is running within Amazon, we actually are auto-scaling the size of the compute fleet. In this example here, you're looking at a plot over time of the size of our compute fleet. And what you're seeing is actually the scaling up and down of the compute fleet. But what's interesting is that through auto-scaling, we're able to do this fully automatically, meaning that it was completely lights out. We didn't have to dial anything. The system basically grew by itself as needed, and then when there was nothing left to do, it kind of, it scales down by itself, basically. This is just another view, and we'll get more into detail with this particular view, but here you can see a different profile shape. So with auto-scaling, you may not always see this nice like Gaussian curve or this kind of bell-shaped curve type of view. You may see other type of behavior too. And in this example here, our operations team set a particular limit to at about 1,032 vCPU instances. So that explains that little flattening there that you see there. And through auto-scaling, it's wonderful because it's one of those ways where you can easily achieve 100,000 vCPUs. How often can you quickly get access to 100,000 processors? And with auto-scaling, you can do that pretty easily. And a lot of what we're doing is actually through hybrid cloud computing. And I'll tell you a little story about something that we did a few years ago for the NASA's OCO2 mission. And OCO2 stands for the Orbiting Carbon Observatory, which is a mission that's monitoring carbon dioxide around the Earth. And they typically run their processing in a typical high-performance HPC type of a supercomputing center. But they typically do a lot of reprocessing, a lot of analysis that reprocesses all the data historically. And one time, the supercomputer that they were running on was scheduled for some maintenance downtime, but they needed to reprocess a lot of data really quickly. And so they were unable to do that. So they gave us a call, and we basically assembled a Tiger team, and within just a few weeks' time, we were able to port the entire, one of their entire full physics processing pipeline into Amazon, and we did it all with auto-scaling. So, and with that, we were actually able to run within the Amazon environment. Actually, we were running in EC2, US West 2, but we moved all the data into US West 1, and then we did all the processing in USS 2. That's because we had faster network speeds into US West 1. But the point is that, we were able to auto-scale up the capacity that US West 2 had. It had much larger capacity at that time. And from that, we were able to scale to thousands of compute nodes really, really quickly. And I think that's one of the things that we've demonstrated is that, at least for us, we got more confidence that not just with auto-scaling, but with EC2 and S3 as well, that it's able to maintain the data throughput rates independent of how large our compute fleet auto-scaled up to. And that little plot there over time of our number of compute nodes compared to the bottom plot there that shows our transfer rate that we were getting, and you can see it correlates pretty well in terms of no matter if we were small or large in our compute fleet, we were getting pretty good sustained throughput rates, which was great. It was a great way for us to validate that this approach works pretty well. And here's another thing that we've learned over the years is that you really want to optimize how you scale in and how you scale out via auto-scaling. In this example here, the scaling out part, one of the lessons that we've learned is that looking at how you do the scale-up events, paying attention to, like for example, the expectation of how auto-scaling does those batch rate size and batch rate increases. Looking at how the internal settings are, for example, you can actually have a better expectation of the behavior of the profile that you would get as you scale up. You can make certain tweaks to get a better profile, to react better. You can have your analysis or compute fleet work better by having a better expectation. And similarly, what we found over the years is that Andre was talking about AZ, or auto availability zone load rebalancing, where they may terminate some instances and reallocate them to another availability zone to kind of balance them out. But what we found is that when we scale up, we tend to scale up in certain multiples of the number of availability zones. What we found is that when you deal with really large-scale compute, you need to do everything you can to kind of minimize certain peculiarities of the overall system. So, over the years, we basically settled on scaling up in these exact multiples as a way to mitigate any uncertainties. During the scale down event or scale in event, on the right there, you can see there's many other things that are going on. And one of the things that we've learned over the years is that when you look at the policy for scaling down, normally, like in a textbook example for Amazon, you would scale down based on like looking at the network utilization or the CPU utilization. When it gets idle to a certain point, like 10 or 20% or even 5%, you would scale down your auto-scaling group. But what we found, though, over the years is that there are certain things that you only know when you're inside the compute nodes, these instances. There may be times where the instances are actually still busy, but they're just not high in CPU or high in network utilization. So there's certain domain knowledge that only the inside the instance knows. So what we've done over the years is that we've changed the scale-in event to basically based on domain knowledge, where, for example, our lead developer, Gerald, there in the audience, he coined the term here, he reused the term here, harikari, or seppuku, and those of you don't know, though that kind of alludes to notions of committing a suicide. These instances, we want them to commit suicide because they know when they're truly done. So we basically have changed our scale-in events to where the compute nodes know when they're done, and they basically will shut themselves down. So they'll communicate back to auto-scaling group, and they'll basically detach themselves from the auto-scaling group, and then they'll self-terminate. We found over the years that that works much better than having a kind of a natural auto-scaling event, because you don't know certain domain-specific details. And the way that we're using auto-scaling, we actually use it a lot with Spot Market. And if you don't know about Spot Market, it's a great way for you to have substantial cost savings. It varies based on the compute node type, but for majority of the instance types, you can get anywhere from 75 to 90%. It varies by demand, by market demand, as well as by instance type. But overall, you can get substantial savings. But the interesting thing about the Spot Market, if you don't know yet, is that Amazon will terminate your instances if the cost of that compute node exceeds your certain bid threshold price that you're willing to tolerate. So if you can tolerate that, you can actually have substantial savings in compute costs. And the software that we use, it's called HiSDS, or Hybrid Cloud Science Data System. What's interesting is we're able to run within an auto-scaling environment within Spot Market and able to ride along with all of those potential terminations due to various things like not just AZ termination, AZ load rebalancing, but also these spot market terminations and many other things like health checks and other types of failures. And in this example here, you're looking at an illustrative view of 3 availability zones where the green areas, the green little dots represent your instances that you would be running. So this is an example of about 1,000 instances, about 333 each, where the X's would dictate for basically which instances are being terminated. And one of the lessons that we've really learned along the way is that when you run in an auto-scaled environment where you can scale up really easily to 1,000 or 5,000 or 10,000 nodes, you start seeing a lot of this behavior. You start seeing terminations happen for multiple different reasons. So one of our lessons that we've learned is that when you run in the spot market at this type of scale, it forces you to re-engineer, re-architect your system to be highly resilient. And so that was a great game changer for us because it changed our mentality to the point where we're basically engineering our systems to treat failures as the norm and not the exception. It's actually very similar to what Netflix has been saying about testing the resiliency of these systems intentionally. And in this example here, we want to talk about the notion of a market maker. And a market maker is basically, what we're looking at here is actually the profile of the spot market cost over time, and what each of those colors there represents the cost of a particular instance type in an AZ. And what's interesting is that this is a market price that we were monitoring when we were doing our own test runs, or actually we're doing our own production runs for that OCO2 mission there. And when we overlay our compute node profile over that, it matches up pretty well in terms of the fact that we became a market maker ourselves. We were impacting the cost of the spot market by the fact of us scaling up and scaling down in the spot market. But there's many things you can do to mitigate this. Obviously, one is to minimize the impact you have on the spot market. You can do that by diversifying the resources that you use. And Spot Fleet really helps you do that. With Spot Fleet, you can actually do that diversification automatically. Another thing that we've learned along the way is something called thundering herd. So, when you scale up, when you use auto-scaling to scale up to, let's say, 5,000 instances, and all 5,000 instances are going to be accessing other APIs, for example. But at these large scales, you have to start paying attention to scalability issues. One of the things that we've learned, for example, is that at these large scales, if you call Amazon's API enough, you may get API rate limit exceeded warnings or errors. But there's many things you can do to mitigate that. And in this example here, imagine you have one of these compute nodes or a few of these compute nodes calling a service. I'll use the example of the Harikari, where an auto-scaled instance says, you know what, I'm done, I'm going to shut down now. But before we shut down, remember I mentioned that we make a call to detach ourselves from the auto-scaling groups? So that's an API call. But if you have one of them doing that, or 2 of them doing that, or 3, or 4, or 10, or 100, or let's say you have 1,000 of them, or 5,000 doing that, what happens is that it starts behaving like a denial of service attack. So that's kind of like what thundering herd is about. But there's many things that you can easily do to kind of mitigate that, especially when you're using this within an auto-scaling environment, is that you want to introduce something called jittering. You want to jitter the API calls. And jittering is just a way that you can introduce like a randomized sleep before you actually make the call. So this type of way, you're actually distributing out, you're smearing out the impact on a particular API call. And it's not just to Amazon's API, it's just considered best practices, even if you're calling it like a database call or other microservices or even REST calls that are outside of a cloud environment. This type of randomization really softens the load, basically, on your infrastructure. This is my last slide. I'll finish up with this thought here. When we look at what the typical NASA missions have been doing in terms of the data volumes that have been generated, we have OCO2 there that was launched in 2009. And then we had, in 2015, we had the SMAP mission. This is another NASA mission. And this plot here shows what the total daily volume that was being generated from each of these missions. It's not the same thing as saying that's how much data is coming down from the downlink stations. It's actually how much data is being processed and generated because of that on a daily basis. And you can see there that between OCO2 and SMAP, it's pretty small compared to InSAR, which is one of the next NASA missions. There are many other missions going on, but I just picked three. I picked these three because they're spaced exactly 6 years apart, and so that you can see the linear progression, and you can see a dramatic jump for InSAR. And I think Tom Soderstrom mentioned this in his talk on the keynote the other day, but this view here shows a comparative view of InSAR compared to the other ones. You can see we can easily get 1 or 2 orders of magnitude larger data. And this is just the data volume for what's called the forward stream processing. And we have many other things running at the same time, which includes bulk reprocessing the data that happens in addition to this. So during those times, our volume rates will actually go up to, at current estimates, are about 150 terabytes per day. And our plan is that we're doing all of this with auto-scaling. The spikes in activity is all auto-scaled, basically. We're doing many other things too, like running it on containers and machine learning to actually mitigate some of this large volumes of data. But the overall impact is that we can't do this without auto-scaling. And I think it all goes back to cost. Auto-scaling has actually been a great way for us to control the cost of that, because why pay for excess compute that you don't need? But with auto-scaling, we can actually control some of that cost. And right now, cost is one of our biggest drivers in the architectural decisions that we're making right now for some of these upcoming missions. With that, I'm going to turn it back to Andre, who's going to talk about some of the future directions for auto-scaling.
Thanks. Wow. Thank you so much, Hook, for sharing with us that compelling example of how auto-scaling's dynamic scaling can be better used for NASA's really important work of better understanding planet Earth. I feel so gratified that we're able to participate in this, and I look forward to working with Hook and the team on their future satellite launches and future space missions. So speaking about futures, let's talk a little bit about the future of auto-scaling. And we've given it a name: application auto-scaling. So here's the idea. We've talked thus far in this presentation about scaling out and scaling in your fleets of EC2 instances. But I bet your applications have more than just EC2 in them, right? So the idea is, why shouldn't all of my elastic AWS resources be auto-scalable? That's what application auto-scaling is. So it's our intent to bring holistic application scaling across all your resources over time. And we've started already to make this a real thing by bringing it to 3 services that I'll tell you about today. The first one is application auto-scaling as applied to Amazon ECS, the EC2 container service. And so with auto-scaling in this context, you have the ability to grow and shrink the number of ECS tasks in your ECS services. And of course, the services, as you know, are housed on clusters of EC2 instances, which are themselves auto-scaled. And so you really do have full-stack auto-scaling in this context. And we have customers like Coursera, the educational technology company, who are using this to increase the agility with which they're able to deliver their service. After EC2 and ECS, the third service to which we brought auto-scaling is EC2 Spot Fleet. So with Spot Fleet, using a single API call, you can actually provision a whole fleet of EC2 Spot instances. You specify the type of instance you're interested in, a bid price that you're willing to pay per hour, and Spot Fleet commissions the whole fleet. Now with auto-scaling as applied to Spot Fleet, you can grow and shrink the capacity of this fleet in response to dynamic scaling policies that respond to changing conditions in your application. More capacity when you need it, fewer instances when they're no longer required. Now, the most recent introduction of auto-scaling was auto-scaling applied to Amazon EMR, the Elastic MapReduce service. So with auto-scaling here, you can specify scale-out and scale-in policies that drive scaling behavior, again, in response to changing conditions. So for example, if you have Apache Spark or Apache Hive applications, they can take advantage of additional capacity brought online by auto-scaling as it's needed. You could use, for example, a metric like yarn memory available to drive a scale-out behavior when memory conditions are low, such that more instances are applied to your problem and it resolves faster. So as you can see, we've already started to make good on this vision of application auto-scaling holistically and brought it to 3 new services, and you can expect to see more of this from us in the coming years. So we've covered a lot of ground today. Firstly, we talked about how you can easily increase the availability of your application using auto-scaling's fleet management capabilities, right? Just a few clicks. Even if you're not interested in scaling, fleet management may be for you. If you think it is and you'd like to learn a little bit more, you can go to our auto-scaling website. There are a number of white papers and other resources there that can help you get started with this. The next thing we talked about was keeping up with demand using the dynamic scaling features. And Hook just gave us an extremely compelling application of how this is being applied to better understand our planet. If you'd like to see other case studies and decide if this may be for you or if it corresponds to the type of application that you have, you can again go to our website. There are a number of case studies there that can help frame this out for you. And you've just heard about the future of auto-scaling, how it's being applied to ever more services. The 3 services that I mentioned are covered in Jeff Barr's AWS blogs. That's probably the easiest way for you to get an introduction to them and get started there. Now, we're not going to do an interactive Q&A today, but I have provided you with a dedicated email address here. It would be our pleasure to be responsive to your questions about this presentation, about Hook's presentation, or about auto-scaling in general. Now, we'd sure appreciate it if you took the time to fill out an evaluation for this session. I'll just conclude by saying it's been a privilege being with you here today. I hope the rest of reInvent is good for you, and we'll see you at the party tonight. Thank you.